Okay, next is section 3.8, variation equations, and we're going to be doing direct and inverse variation models. And the main things you need to know here are, if we're doing a direct variation, your equation is y equals k x to the n. If it's inverse, it's k over x to the n. Okay, so the only difference is whether the x to the n is with the k or beneath the k in the denominator. And your variation constant is k. Those are things that we're just going to apply that you need to know. But after we use them enough, it's like most formulas that you're required to know. Once you've practiced it enough, it's not that big a deal. We're going to start with swimming underwater. And it tells us that the pressure in your ears varies directly. That means we're using direct variation with the square, okay, that's going to be your exponent, of the depth at which you swim. Okay, and it says at 10 feet below the surface, you feel 4.3 pounds per square inch on your ears. First thing we're going to do is find the variation constant, all right, that's K, and we're going to write the variation equation. So I know that if it's a direct variation, it's y equals k times x to the n. So I'm just going to start with that part. I know that it's y equals k times x to the n is my direct variation equation. And I'm going to take the information I know. I know that my y, okay, and again, think of x and y as input-output. The input is if you're at 10 feet, what's your output? It's 4.3 psi. So 4.3 is going to be my y value. I'm just plugging it into this. Equals k, that's what I'm looking for, times 10. Okay, that's my x value. And we said that it varies directly with the square, so that means my exponent, my n, is to the second. So that means I've got 4.3 equals k times 10 squared is 100, so it's 100k. Divide both sides by 100 to get k by itself, and k equals 0.043. Okay, so that's my constant for my variation. And then if I rewrite the equation, all I'm doing is I'm plugging in to my direct variation equation is going to be y equals my k, which is 0.043. Notice I went to 3 decimal places. Then whatever my x is, and then my n is squared because this is a square variation. Okay, so that's how I solve for my k, and that's how I solve for the get my equation that I can apply to any situation. So now that I know that this is what I can apply to any situation because of how it varies, I'm going to determine the pressure I would feel in your ears 50 feet below the surface. Okay, so this is going to be the x value that I'm going to put in. This is the equation I'm going to use. So I have y equals 0.043 times my x, which is 50, squared. Right? Because my equation is, let me put that out here, y equals 0.043 x squared, so that's what I got there. I plug in 50 for my x, and if you put that in your calculator, remember you square first and then multiply because of order of operations, you get 107.5 pounds per square inch, and that would be your answer. Okay. Now we can work it another way. If I know what the pressure is on my ears, I can find out how far down we're swimming. So again, I'm going to take my original equation, which was y equals 0. This is always true for this situation. All right, but this time I don't have x. This time I have y. So I have 65 equals 0.043 x squared. So I'm going to divide both sides by 0.043 because I'm trying to get too many zeros there. I'm trying to get the x by itself. And I get 1511.6 equals x squared. To find my x, I'm going to take the square root of both sides. And when you take the square root of 1511.6, you get 38.9 feet. That's how far you are below the surface. All right. So what we're doing is we're finding a model that we can then apply to different situations. Okay. Next one. This one is an inverse variation, because you knew that was coming. This time, The force you have to put on a wrench handle to loosen a rusty bolt varies inversely with the length of the wrench handle. There we go. If it's 91 inches long, it requires a force of 90 pounds. If it's 21 inches long, it requires a force of 90 pounds. So if I put in 21, I get out 90. So this is going to be my x and this is my y. My equation for inverse variation is y equals k, and this time my x to the n is on the bottom. It does not say whether it's squared or cubed, so that means it's going to be an n of 1. So when I plug this stuff in, my y, my output is 90, equals k over 21 to the first, because there's not a square or a cube or any kind of exponential variation on it. In order to get the k by itself, I'm going to multiply both sides by 21. And I end up with k equals 1890. That's my variation constant. So my variation equation is going to be y equals my k, 1890, over whatever my x is. And it's x to the first. Okay. So that's the equation I'm going to use in my next equation, or my next problem. And this is asking what the force would be if I had a 7-inch wrench. So if I put in 7, that means I'm going to put in 7 for x. So I have y equals 1890 over 7. And that's going to require 270 pounds of force. Okay. And again, if you know how many pounds of force we have, we can find out how long the wrench is going to be needed to loosen the bolt. Okay, remember my variation equation for this situation is 1890 over x equals y. This time I know that my force is 50 pounds, so that goes in for y. And then I have 1890 over x. If I put this 50 over 1, I can cross multiply. 50 times x is 50x. 1890 times 1 is 1890. Divide both sides by 50. And x equals 37.8 inches is how long of a wrench you need if you only have 50 pounds of force that you're going to use to loosen that bolt. Next, okay, the number of houses that can be served by a water main is directly proportional. Okay, so that is a direct, it's not inverse, it's a direct variation to the square, that's going to be my exponent, of the diameter of the water main. Water main 10 centimeters in diameter can supply water to 50 houses. So if 10 centimeters goes in, the output is your 50, this is your x and your y. We want to find the variation constant first. Well, my variation equation for direct variation is y equals k x to the n. And so I'm going to put in 50 for y equals k. My n is 10, and we did say it was the square of the diameter, so 10 squared. That means 50 equals 100k. Divide both sides by 100, and my constant is 1/2. So my variation equation is going to be y equals 1/2 x squared, because it is the square of the diameter. Okay, so when we use that to work out all kinds of different situations. So we've got a water main that's 30 centimeters in diameter. How many houses can that serve? Well, we're going to take our variation equation, which is y equals 1/2 x squared. Right, and I've got a 30 centimeter in diameter, so that goes in for x. So I have y equals 1/2 30 squared. 30 squared is 900, and half of that is 450. So y is 450 houses. So if I've got a water main that's 30 centimeters in diameter, that will serve 450 houses. Well, let's say we're planning a new subdivision, and that new subdivision is going to have 1,500 houses. And I need to know how big a water main I need. So I would take y equals 1/2 x squared. I need 1,500 houses, so that's going to go in for y. So I have 1,500 equals 1/2 x squared. To undo the 1/2, I'm going to multiply both sides by 2. That gives me 3,000 equals x squared. And of course, then you'll take the square root of both sides. And when you take the square root of 3,000, you get 54.8 centimeters. So I need at least 54.8 centimeters in order to serve those 1,500 houses in the new subdivision. And that's the diameter of that water main. And that is the end of section 3.8.